Today the topic which I am going to cover is the continuation of my previous uploaded video. So here degree of kinematic indeterminacy for beams. Here in today's video I'll be covering in case of the beam neglecting axial deformation. So in my previous video which I have covered was considering the axial deformation. So in today's video I'll be taking for beams, but we have to neglect the axial deformation. So in my previous video I have already explained you about what is axial deformation. So here also again I'll repeat what is axial deformation. We have three type of deformation. The first one is axial deformation, and the second one is vertical deformation, and the third one is moment. Okay, so here just an example. Here in case of the fixed beam we have three unknown reaction, that is vertical, horizontal and the moment. What does this mean? So here in the fixed beam what happened, this beam can be deformed vertically, horizontally and along the moment. So here in this case what happened, we have to neglect the axial deformation. That means we have to neglect this deformation. Okay, this is the axial deformation, or this is the horizontal deformation also we can see. So now here in case of beams neglecting the axial deformation, we have a formula for finding the degree of kinematic indeterminacy, which is denoted by the term d suffix k. So d suffix k is equal to 2j minus r plus a. So this is the formula for finding the dk value for beams neglecting axial deformation. So here in this case what happened, we have to neglect this axial deformation. So for an example, this is a beam which one end is hinge and the other end is fixed, and here one hinge is present. So in this case what happened, we have to use this formula. Okay, so here j is the number of joints, and how many joints are here? This is 1, 2 and 3. We have 3 joints here, and the number of unknown reactions. Now in this case how many unknown reactions? Here in case of the hinge there is 2 unknown reaction, and in case of fixed beam there is 3 unknown reactions. Okay, so total number of reaction is 1, 2, 3, 4 and 5. So we have 5 unknown reactions. And a, to find the a we have a formula, that is m dash minus 1. Here m dash is what? M dash is the member which is connected with this hinge. So in this hinge how many members are connected? 1 and 2. So m dash value is 2 minus 1 is equal to 1. Therefore the value of a is equal to 1. So here we have a value of j, r as well as for the a. So now we have to put all the values in this formula, that is 2j minus r plus a. So 2 into j is 3 minus r is 5 plus 1. So 3 to the 6 minus 5 plus 1. So here 2 3 is 6 minus number of unknown reaction. Okay, sorry, what I have done here is a value is 1 and here dk value. Here the reaction, unknown reaction, here we have to neglect the axial deformation, right? So if we neglect this axial deformation, we have to assume that this force is not present here. This force is not present here. Then remaining will be 1, 2 and 3. Okay, so here in this case the number of unknowns is 3. So here also we have to put 3. So 3 1 is 3, 3 2 is 6, and here it will be 3. So the answer will be 7 minus 4 is 7 minus 3 is 4. So dk value is 4. So for this type of beam, the degree of kinematic indeterminacy is equal to 4. And again, okay, suppose if we don't remember this formula, we have an alternative way of finding the problem. So suppose in my previous video also I have told you about this alternative method. So again I'll repeat the same. So this was the question. One end was fixed and the other is hinge, and one internal hinge is present. Now here we have to separate this. Okay, if we separate this, what we'll get here, hinge and the other is fixed and one internal hinge is there. Okay, so here how many? 1 2 and 3. 1 2 and 3. So here in the hinge 1 and 2, here 1 2 3 and 4, and here 1 2 and 3. Now here this is case of we have to neglect the axial deformation. We have to assume that this axial deformation is not present. So we have to nullify those horizontal forces which is acting here, this one. So now what will happen, this and this will cancel out. Here DOF is equal to 1, here DOF is equal to 3, and here this and this will cancel out, this and this will be cancelled out, DOF will be 0 here. So total DOF is equal to 1 plus 3 is equal to 4. Okay, so dk value is 4 here. Now don't get confused about DOF. DOF is nothing but the degree of freedom. This is the other name of the kinematic indeterminacy, degree of kinematic indeterminacy. Okay, so here by using the formula also we got the dk value as 4, and without using the formula we are also getting the value of dk is equal to 4. So either way we can use. Okay, if you don't remember this formula, then we can use by this alternative ways. Okay, now I'll solve another problem. Okay, so here one end is fixed and the other end is also fixed, and in between this beam, fixed beam, two roller supports are there, and between this one UDL is acting, and here in between the fixed and this roller and the fixed and the roller, here 2 point load is acting, that is P. Now we have to find the degree of kinematic indeterminacy for this type of beam. So we have already know the formula for finding the degree of kinematic indeterminacy, that is 2j minus r plus a. Okay, so here in case of this, how many j's joins is equal to 1 2 3 and 4. Their number of joins is 4, and the reaction is equal to the reaction, how many reaction is for roller 1 2, from here this will be, and this will, this and this. Okay, because here we have to neglect the axial deformation, so we'll not consider the axial deformation here. So total number of unknown reaction will be 1 2 3 4 5 and 6. Okay, 6. So a value will be 0 here because there is no internal hinge here in this beam. So now we just need to put the values in decay formula, that is 2 into 4 minus 6 plus 0. So 4 1 is 4, 4 2 is 8, minus 6 is equal to 2. So by using the formula, the decay value comes out to be 2. Now again we'll see by the alternative way of finding the decay value. So here what we have to do is like this we'll do, and then the fix and the support and the fix will separate all those now. So here we have what we have to do, we have to avoid those. So here what happened, one axial will avoid, so here also, and then what will happen, here and here this will get cancelled out, here one, and here. So okay, so what will happen here, this to this and this will get cancelled, this and this and this and this will cancel out. So here only 1 2, so here decay value will be 2. So see, this is the alternative way of finding the decay value here. So we are getting the same answer, that is the decay is equal to 2, and by using the alternative method also we are getting the same answer, that is 2. Okay.